Hi, in this video we'll be talking about rounding. A little trickier with significant figures. So if you're thinking rounding, I got this is elementary school stuff, give this a watch. First, make sure you've seen the significant figures video because we're rounding to X amount of significant figures for a bunch of different measurements. And if you don't know what significant figures are, you'll be lost. So make sure you watch this significant figures video first and then rewatch this video as often as you need to until you get it down. Let's start with this measurement, 12.3450. How many significant figures are in this measurement? Take a moment, see if you can figure that out for yourself now. The answer is 6. 6 significant figures because there's a decimal point present in this measurement. We start on the Pacific side or the left side of the number, and we start counting at the 1, and we don't stop counting until we get to that 0 on the other side, including that 0. So 6 significant figures in this measurement. Now let's practice rounding to a smaller number of significant figures. If I want to round to 5 significant figures, I have to look at what I want to keep and what I want to get rid of. I want to keep these 5 digits because they're my 5 significant figures that I want, and I basically want to remove this digit here. As long as it's after the decimal point, I can just get rid of these. If it's to the left of the decimal point though, if I want to remove those as significant, I have to just make them zeros. But more on that in a second. Does this 0 promote the 5 up? Now think back to your elementary school rounding rules. 0 to 4 leaves the number alone. 5 or higher makes the number promoted to the next digit. So a 0 does not change the 5 at all. The new measurement becomes 12.345. That's got 5 significant figures in it, and I've done it correctly. How about 4 significant figures? Well, I want to keep this, and this. So I want to get rid of this 0, which I know I can do. And then I want to look at that 5. Is the 5 going to promote the 4 up to a 5? Yes, it will. So this new measurement becomes 12.35. To 3 significant figures, I want to keep the 1 place and the 2 place and the 3 place. And I want to look at this 4. Does that 4 promote the 3? No, it doesn't. So this just becomes 12.3. We've basically gotten rid of the 0 and the 5 and the 4 there. How about to 2 significant figures? Well, I want to keep the 1 and the 2. Does the 3 bump up the 2? No, it doesn't. So this is just 12. And then finally to 1 significant figure. Well, this is kind of what I was talking about before. I can't just keep this. The 2 doesn't bump the 1 up. I can't just say this is 1. That totally changes the size of the number. If I've gone to the left side of the decimal point here, any of these digits over here, I have to make zeros if I want to make them insignificant. So because the 2 does not promote the 1, this 2 doesn't just go away, it becomes a 0. So this is 10. Let's try another measurement, 0.05082. How many significant figures are in this measurement? Again, pause the video, try this on your own, and then hit play when you think you have the answer. The answer is 4 significant figures. So let's practice rounding to a smaller number of sig figs. If I wanted 3 significant figures, in this measurement, these first zeros are not significant. So they shouldn't be part of our consideration. I'm essentially just looking at this part of the number when I want to round it. 3 sig figs, I want to keep this as my first significant digit, this is my second, and this is my third. So I want to look at the 2 compared to the 8. Does the 2 bump the 8 up? No, it doesn't. So 0.0508 is my 3 sig fig number. How about the 2 sig figs? Well, I want to keep the 5 place and the 0 place. Does the 8 bump the 0 up? Yes, it does. So 0.051 is my number with 2 significant figures in it. How about with just 1 sig fig in it? Well, I'd be keeping the 5 place. Is the 0 going to bump the 5 up? No, it shouldn't. So 0.05 is the measurement to just 1 significant figure. Okay, let's look at another example, 617.625. Try this one all on your own. I'm going to show you how many sig figs are in this number. It's 6. And so let's practice rounding to 5, 4, 3, 2, and 1 significant figure. Pause the video here, try this on your own, and then I'll show you the answers. To 5 sig figs would be 617.63 because that 5 bumps up the 2. To 4 would be 617.6. The 2 doesn't change the 6 there. To 3 sig figs would be 618. The 6 promotes the 7. To 2 significant figures, it's 620. That 7 promotes the 1 to a 2, but then the 7 just becomes a 0. And then finally, rounded to 1 sig fig is just 600. Common error I see students make is they think, oh, 1 sig fig for this number, well, that new number is going to be 6. And that's a totally different number. You have to change any of the digits to the left of a decimal to zeros if you want to make them insignificant. If I told you I was paying you $617 for something, but I was just going to round it to 1 sig fig and pay you $6, you'd be mad at me. So just think about that. All right, this last one is really tricky because we're going to have to use scientific notation to help us with it. See those 9s there? There's a promotion nightmare going on. So this has 5 sig figs in it. If I want to round it to a smaller number of sig figs, I'm going to have to use scientific notation. Here's why. To 4 sig figs, these first 4 digits would need to be significant. But the 9 bumps the 9 up to a 10, which we all know a 10 would bump this up to a 10, which would bump this up to a 4. So really, I want to round to the value 54,000, but I need that to be expressed in 4 significant figures. This number here currently has 2 significant figures in it. So how do I represent this as 4 significant figures? I need scientific notation. If I can take this number, 5.4 times 10 to the 4th, and now I can just change this number up in front to make 4 significant figures. Whoops, sorry about that. 5.400 has 4 significant figures in it. Then I just include that times 10 to the 4th, and there's my measurement to 4 significant figures. Certainly, in my opinion, the trickiest part of sig figs is this right here. See if you can do this with 3 significant figures. I want to keep that 54,000. I want to put it into scientific notation, and I want to have 3 sig figs. This would just become 5.40 times 10 to the 4th. When we get down to 2 sig figs, check out what number I'm using here. This number here has 2 sig figs in it. So I certainly could use this as my 2 sig fig rounded measurement, or I could keep going with this scientific notation stuff. So if I have 5.4, that's got 2 sig figs in it. 5.4 times 10 to the 4th is the same thing as 54,000. Both of these measurements have 2 sig figs in it. So that'll work. What about 1 sig fig? With 1 sig fig, I want to go to 50,000. So I could just do 5 times 10 to the 4th, or I could just put 50,000 because both of these measurements have 1 sig fig in it. So rounding with significant figures, there's certainly a lot to look at here. And the more you practice this, the better you'll become at it and the more confident you'll be in working with measurements. Thank you.